Hi, it's Mrs. Moss here, and we're going to stop talking about the Earth's crust and the surface of the Earth, and we're going to get deep. We're going to go underground. We're going to start talking about the Earth's interior and the inside layers of the Earth. Looking at this picture, you can see that beneath the surface we have a bunch of different layers, and at the very center of our Earth is the core. So we're going to talk about each of those layers and what they're made of and find out a little more information about them. This picture is just a simple diagram, but it shows the Earth as being compared to an apple. Well, you might think that seems very strange, and in a way it is, but if you look at it a little more carefully, you see some comparisons, some similarities, right? So the apple has a skin, Earth has a crust. Underneath that, we have the pulp or the fruit that we bite into. Well, they have the mantle underneath the Earth. Going even further, there's a core at the center of the Earth, and at the center of the apple is where the seeds are. So this little picture just kind of goes along and compares the two. There are two types of Earth's crust that we see at the very top of the surface. We have the continental crust, which is the land, and we have the oceanic crust, which is the land that's at the bottom of the ocean. This diagram shows a picture of the side of a slice or an outcrop of the Earth, and it breaks it down into the various layers. So you see at the very top we have the crust, and it goes into a little more detail up at the top. You can see here we have the oceanic crust, and that's a very thin layer that's underneath our water or our oceans, and that leads into the continental crust, which is a thicker layer, but we'll learn more about the differences in just this next screen. Let's talk about these differences. So the continental crust is thicker, as we saw in that diagram. The oceanic is thinner. The composition, the continental is made of granite, which we know is an igneous rock, and the oceanic is basalt, another igneous rock. Well, we also know that if it's granite, then it has to be felsic, and if it's basalt, it has to be mafic, which makes the color of the continental lighter and the oceanic color a little darker. Similarly, we would find that the density is lower in continental and higher in density. So you have to be careful with this because the oceanic is thinner. We tend to think of it as less dense, but because it's thinner, it's more packed with molecules, so it's actually more dense than the thicker continental crust. The lithosphere, this continental and oceanic crust that I was just describing, sits on top of a layer that's partially molten or magma, plastic like rock, and it has the ability to flow like magma. This layer is called the asthenosphere, and it allows the plates in the crust to move. We're going to get into that as we talk more about plate tectonics, but it's important to know that this layer exists just beneath the Earth's crust. Here's a larger picture of it, a side view, and you see the orange that make up the asthenosphere is magma, and it does have the ability to move because it has different densities. You see it creates a convection current right underneath the Earth's crust. So we make inferences about the Earth's interior composition, which you see on this note slide that it's made of nickel and iron. And we learn about that, or we make these inferences based on the study of meteorites, believe it or not. And we also study seismic waves, which are earthquake waves. We will also get more in detail about that in our next couple of slides when we talk about earthquakes. But just so you know, that's how we're able to make these understandings and come to these conclusions about the Earth's interior, because we have certain evidences that we can look at to help us come to these conclusions. Need to memorize this because this is all on page 10 of your Earth Science reference table. Let's take a moment to take that out. If you need to pause the video, please do so. I'm going to continue on and talk to you now about this page of the reference table. There is a lot of information on here. So first we see, if we go work from the top down to the bottom, okay, we see we have the lithosphere, which, as we said, it makes up the Earth's crust, and it's the continental crust and the oceanic crust that create the lithosphere. If you look over to the side where I just circled, we see that the granitic continental crust, or the continental crust that's made of granite, has a density of 2.7 grams per centimeters cubed, whereas the basaltic ocean crust, or the ocean crust that's made of basalt, is more dense at a 3 grams per centimeters cubed. Okay, so as you go down in the levels of the Earth, this corresponds to the density numbers and the information that we get in this circle. So if we go below the surface and we look right here at the stiffer mantle, okay, this whole dotted portion represents the stiffer mantle. That has a density of 3.4 to 5.6 grams per centimeters cubed. Moving downward, the Earth's outer core has a density of 9.9 to 12.2 grams per centimeters cubed. And our inner core, which is made of iron and nickel, has a density of 12.8 to 13.1 grams per centimeters cubed. So if we're going to look at this in terms of a relationship and how we go from the top to the center, the relationships that we can create with this density is that as we go deeper into the Earth's surface, the density gets greater. So it's a direct relationship. The density increases as we go deeper into our Earth. Now I want to show you another way to use this chart, because it's not just the top portion that we can use to tell us information about each layer, but we can also look down and use the bottom part of this chart to help infer about the pressure and the temperature within the Earth. So just going down, you see from each layer, the dotted lines correspond to the layer at the top. So if you look at this top, the asthenosphere, the plastic mantle, these two thin dotted lines come all the way down. And our top portion of this chart shows that the pressure underneath here the unit is million atmospheres. And if you look, it is just here at the 0 level. But as you go deeper into the Earth, you notice that there is an increase in pressure as you get closer to the core. Continuing down this chart, if we look down at the temperature, we can see that the temperature is increasing as well as we go deeper into the Earth. So within this asthenosphere, we can see between these two dashed lines, where the green outline is in your screencast, the start at the very top of the asthenosphere starts at about 0, and then 1,000, and then it increases to about 2,500 Celsius. Okay? And if we go along and we look at the stiffer mantle now, we're going to look downward using these dotted lines to guide us, as we did with the first one. And we see again an increase in the pressure and an increase in the temperature. Now, something else that you can notice along this line, excuse me, they have the melting point. Now, if you notice, excuse me, this line is below the melting point. So we're still at a solid when we go through this material. The stiffer mantle is a solid. If we continue further into the Earth and the layer of the outer core, well, then we see an interesting change here. You may notice that this darker line, the temperature, crossed over the melting point. That means the actual temperature of the outer core is hotter than the melting point. So that tells us that this outer core is a liquid. It is melting. The material is melted at this point. So that's important to note in your reference table. You can write next to outer core, liquid. Moving on, the inner core, made of iron and nickel, is again below this melting point. So it turns back into a solid once we hit that inner core. So using the temperature chart, using the pressure, we can see the depths at which we're talking about as well as the pressure and the temperature. If you look at the bottom and we line up this black line, let me find my mouse, here we go. This black line will correspond if you go down to see where the depth is at that level. So if we're looking perhaps at the outer core, I'm going to find this section. I'm going to see where the black line is, and I can see that this level starts from 3,000 kilometers down, and it goes as deep as like about 5,000 or a little over 5,000 kilometers down. So that's how we read this chart. It is complicated, there's a lot to it, but with some practice, I'm sure you'll get a good understanding of how to use it. Okay, rewind and go back if you want to replay anything or if you didn't understand anything. And we'll end there for now. I will see you next time.